And then one more challenge, I have to now convert the integral form back to definition form. And so remember, in integral form, this is my a, and this is my b, and this stuff is f of x. So to get back to the limit form, the definition part, of course, n is going to infinity. That's all that tells me, is that the number of rectangles is getting greater, meaning the size of the rectangles is getting smaller, so that there's less chance of error by finding the area of smaller rectangles, since they don't necessarily extend outside or too short inside the curve. Okay, so remember, I'm supposed to have f of x sub I and delta x. So now keep in mind that in order to find our delta x, we had to do b minus a over n. And since I know b is 4 and a is 1, I can just plug those in. So I get 3 over n. So I just found this part. And now to find f of x sub I, remember x sub I is a plus delta x times I. Well, I know a is 1, and I just found delta x. And then I want to find so I found the x values. Now I want to find their corresponding y values. And so I'm supposed to take that x value, that generic x value, and plug it into my function, which means I'd be doing 1 plus 3 over n times I and squaring that and plus 1. And so all of this is going in for here. So I can write the limit back out again. And then that's going to need a big set of brackets and some extra parentheses. You can never have enough parentheses. And there, my favorite calculates is my final answer. Beautiful. See you tomorrow, kids.